This is a mini chemistry lab. I designed it for people who want to get started in experimental chemistry or who have very limited space. My first inspiration was Sherlock Holmes, who had a mini chemistry lab on a side table in his flat at 221B Baker Street, where he conducted experiments in organic chemistry, blood tests, and poison analysis. My second source of inspiration was this old chemistry book, which I used when I was 10 to set up my first chemistry lab in the basement of our home. Alcohol burners are usually used in small labs like this, but I wanted something electric that would be easier to control and poses no fire hazard. That's why I built an electric test tube heater. For safety, a thermal switch is used that shuts off the power at 250 degrees Celsius. The heater's base is a PTFE disc with a diameter of 50 mm and a length of 20 mm. Here you can see an initial test. A cheap PWM speed controller is used to control the temperature of a 12 volts 60 watts cartridge heater for 3D printers. The aluminium body was then insulated with aluminium-faced mineral wool. I then built a housing for the PWM controller out of plywood scraps, some aluminium sheet and 90 degrees aluminium angles. The base plate is made of multiplex plywood and measures 300 by 300 by 12 millimeters. I used a router to cut a thymorector pattern into it since it looks nicer that way, but you can skip that step. In addition, I drilled 10 mm holes into a beechwood rod that has a diameter of 20 mm. I also made a test tube rack myself out of 5 mm plywood, as well as a funnel holder out of 12 mm plywood, to which I glued a 10 mm beechwood rod. In the next phase of construction, I glued a test tube rack to the base plate, drilled a few more mounting holes, and then treated it with wood stain and linseed oil. The rubber feet ensure that the base plate sits securely on the surface and does not slip. Next, I installed the PWM controller and the test tube heater. Please note that I insulated the thermal switch connection with silicone tubing so that the aluminium foil cannot cause a short circuit. In the meantime, I had fitted the housing with the included potentiometer, an on-off switch and a power jack. I also glued in a small ventilation grill and installed a waterproof cable grommet. When using screw terminals, you should always use wire ferrules. If you don't know anything about electronics, ask someone who does for help or watch tutorials. I always say that skills are like Lego bricks. The more you have, the more complex things you can build. You may have already wondered what the round cutout in the base plate is for. Well, an aluminium disc is glued into this cutout in case you ever need to place a hot flask there or burn something in a crucible. I use oven cord adhesive, which is rated for temperatures up to 950 degrees Celsius. Just an idea. You could also use the aluminium disc to build a small hot plate, maybe even with a magnetic stirrer. The 4 holes in the base plate are used to secure the lap stand. Off camera, I also made two lap clamps out of wooden test tube holders and a 10 mm beechwood rod. Wooden closest pins work too, but they don't open as wide. Next, I will show you how to build a mini Liebig condenser using a reaction tube, a few pieces of 6 mm borosilicate glass tubing and some stoppers. I'm using glycerine as a lubricant. Instead of the reaction tube, you can also use a PVC tube or one made of PMMA. When heating liquids in test tubes, you must always use boiling chips, otherwise a phenomenon known as superheating will occur. Here you can see an aluminium cup used to store steel rods, scissors, tweezers, spoons and so on, which fits into the last remaining hole, and a multimeter with a thermocouple that serves as a thermometer. The laptop power supply provides 12-volt DC and up to 10 amps. That's it for now. Thanks for watching. Stay true, stay you.